Welcome everyone to our course, engineering course on digital circuits design. Um, Anyone having attended our course or has attended our course in the past knows that we pay heavy emphasis on whenever we talk about titles of a course or a book. Please pay attention to the words, the keywords, and if you're interested in finding the detail, historical evolution of those keywords or words. Greatly appreciate visiting Britannica or similar quality website in order to understand the details because that's an area in itself. In this particular course, we will be heavy, basically focusing on the basics of designing digital circuits. So we offer these courses under Quantech Field Institute, which is an affiliated organization under Soft Galaxy Technologies Inc. Anyone interested in connecting with us, visit our LinkedIn profile page as shown here, or send us an email at info@hsclouds.org or softgalaxy.hsclouds@gmail.com. Here, HS stands for humanity serving, and clouds as the last word. So, one of the key things we believe in that there is no shortcut to glory, and that's what we try to emphasize to our students that you need to have a passion towards whatever you want to achieve in your career, and let the rest, the nature take care of your journey of in your life. Yeah. So, but there is no shortcut. There is no short path to achieve a glory in a particular field or in a particular project. Yeah, so by taking this course, here are our objectives relating to course and career. To give you a basic understanding on the principles, techniques in designing and working with digital circuits or systems. You can be a digital systems and circuit designer depending on how much you practice, how much you pay emphasis on this particular course, and go well beyond just this course learning and practice on your own to become kind of to reach this particular level, because this is a very kind of a responsible job to be a digital systems or a circuit designer. And the least that you can become a digital systems technician by taking this particular course. So here's the marks distribution. If anyone has attended our courses in the past, they know that how this distribution goes. But just as an introduction, 10% will be assignment. Assignments includes any lab work we will give you, so that will be a part of that 10%. Our intention is to give you 5% before the midterm relating to assignments and 5% before the final. The lab work, you will be testing on these assignments plus lab work as lab work exam, or as 20%, which will be a 1 hour exam, as 10% on the day of your midterm or on the day of your final. So before the midterm, you will be given that 10% exam, and you will be given a break, half an hour, 1 hour before you take your midterm. Similarly, on the day of final, the 10% the lab exam will happen first, followed by a break and your final exam, which will be an hour and a half long. Our focus is to do at least 4 industrial tours in relation to digital circuit design, giving you the kind of a practical knowledge on how industrial and consumer use this particular area in making their lives or systems better, fulfilling their needs. So the topics covered will be, because when we talk about, so these are the topics, snapshots from one of the reference books we will be following. So when we talk about digital systems or the word digital, we and we want to excel in this particular area. One thing is very important for everyone, all of the listeners to understand, the students, that the world or the universe is not digital. Universe is analog. Okay, so for our own, when I say the word our, for humans ease, we digitize the analog information, and and that digitization help us process further on, and that's why the word digital is there. So it's very important for anyone to excel in, because nowadays in our communities globally, digital systems are basically everywhere. So in order to understand digital systems, digital circuits, digital logic, very important to understand the basics. And that's exactly what we are going to do in this particular course. We will discuss what a numbering system is. Okay. We will discuss what the Boolean algebra is. We will discuss the basics of digital circuits, commonly used Boolean circuits, the flip-flops, that's as a separate topic, state machines, interfacing digital circuits. So these are all very important topics in relation to acquiring the knowledge required to be have a passion to understand digital circuits, digital systems. Okay, so that's very important to understand here. Any questions you have, please write down in your notebook for our Q&A sessions, and uh, we will satisfy with the answers in order to clarify those questions. Okay. So just carry on. So anyone taken our prior course, Introduction to Electronics, Electrical and Digital System or Circuits, knows that we have covered these basic logic gates we use in a digital design. Um, uh, that's a symbol of an AND gate, symbol of an OR gate, symbol of a NOR gate, a NOT gate, NAND, and an exclusive OR gate. One thing very easy, just as you can see, and NAND are the so as you can see here, and NAND, they look the same with the difference of this small notch, and that small notch wherever you see is basically represent a NOT operation. Just as a So similarly, you have an exclusive OR gate. Exclusive NOR gate is a similar gate with a notch in the end. So we will discuss, we will review the basics we have learned in the past, but these are the basic logic gates when we talk about designing a digital circuit. This is the truth table of the gates shown before. It doesn't include that particular symbol, which we call it as a buffer. We have covered that in our prior courses. But just as a clarity, a buffer is nothing more than whatever comes at the input goes at the output. As you can see, 0 and the output is 0, 1 and output is 1. It's mostly used to for current amplification, but in the logical levels, it's basically the same input and same output. An inverter is basically an opposite of whenever the input is 0, the output will be 1, and if the input is 1, the output will be 0, and this notch not necessarily has to be at the output, it can be a notch in the beginning as well. And we have discussed that in our prior basic course. This is the truth table of an AND gate. So both input has to be 1 in order to get a 1 at the output, else everything else will be 0. As you can see here in the truth table, all zeros except 1 when the inputs are both 1. Okay? And since this is an invert operation of an AND gate, because of this notch, we call it as a NAND gate. And as you can see, it's basically a flip. The output is simply a flip of a NAND gate output. So all ones except the last one is 0. We also learned in our prior courses that any digital circuit can be designed using NAND gates only, and we covered the basics. We did the Boolean, simple Boolean equations to show that particular concept. So that's what the popularity of a NAND gate is, that you can design any logic circuit using simple NAND gates. So let's carry on. So this is the OR gate, this is the NOR gate. An OR gate is any of the input 1 means the output is 1. As you can see here, any of the input 1, the output is 1. When both are 0, the output is 0. And NOR is simply a flip version of an OR gate. And as you can see here, it's 1 and all zeros. Okay? That's what the NOR gate is. This is an exclusive OR gate and its associated truth table. In an exclusive OR, when the inputs are different, the output is 1. As you can see here, the inputs are different. A is 0, B is 1. In this case, A is 1, B is 0. The output will be 1. When the inputs are different, the output is 1. And when the inputs are similar, the output is 0. So if you remember, it's very easy way to remember the exclusive OR gate truth table. If you remember exclusive OR, NOR is nothing more than a flip version of that. As you can see here, it's 1, 0, 0, 1. That's how we represent an exclusive OR operation. And that's how we represent an exclusive NOR operation on a given inputs. So we'll be covering, going through these references, and when we talk about digital circuits or digital electronics, there's so many references. But again, some of the references are shown here, not necessarily all the references, but the focus is the students following this particular course highly encouraged to focus on the given information during the lectures, the slides. Attend Q&A session, ask a lot of questions in order to bring clarity, and be able to do good in this particular course. Okay, so thank you very much. Anyone interested in connecting with us, send us an email or connect via this LinkedIn profile, and looking forward. Take care.